Welcome to MRL. In this learning session, we'll learn about a quadratic polynomial. Now, what is a quadratic polynomial? A polynomial of second degree is called a quadratic polynomial. For example, 3x squared plus 2x plus 5 is a quadratic polynomial because it is a second degree polynomial. Now, the general form of a quadratic polynomial, p of x is equal to ax square plus bx plus c, is the general form of a quadratic polynomial because it is a second degree polynomial and the variable is x. So, x is a variable, a is the coefficient of x square, b is the coefficient of x, and c is a constant, and therefore ax square plus bx plus c is the general form of a quadratic polynomial. Now, the zeros of a quadratic polynomial, the zeros of a quadratic polynomial are the value of the variable which makes the value of the polynomial 0. Now, the quadratic polynomial being second degree polynomial, it will have at the most 2 zeros. That means it can have 1 0, 2 zeros and no zero. Now, the relationship of zeros and coefficients of a quadratic polynomial. If p of x is equal to ax square plus bx plus c is a quadratic polynomial, if alpha and beta are the zeros of a quadratic polynomial, then the polynomial can be expressed as the product of two factors, x minus alpha and x minus beta. Therefore, we have ax square plus bx plus c is equal to k times x minus alpha into x minus beta, and these are the factors and k is a constant. Now, by multiplying kx and k alpha into x minus beta, applying the distributive property, opening it, we get kx square minus k alpha x minus k beta x plus k alpha beta, and now in this we have x and k common here, therefore we can put alpha plus beta in the bracket, and therefore comparing the coefficients of x square and the constant, we get ax square is equal to kx square, x square cancels, and a is equal to k, therefore k is equal to a here. Now, taking the next, that is bx is equal to minus times k alpha plus beta into x, x will cancel, we have b is equal to minus k times alpha plus beta, but k is equal to a, therefore it is minus a times alpha plus beta, or alpha plus beta is equal to minus b by a. Therefore, we have two relations here. One is alpha plus beta, which is minus b by a, and that means alpha plus beta is equal to minus coefficient of x, p is the coefficient of x here, and coefficient of x square, a is the coefficient of x square. Therefore, we have an important relation between the zeros and the coefficients of a quadratic polynomial, that the sum of zeros is equal to minus b by a, or sum of zeros is equal to minus coefficient of x upon coefficient of x square. Now, the second important relation is by taking c is equal to k alpha beta. Now, why is c is equal to k alpha beta here? We can compare c and k alpha beta, therefore c is equal to k alpha beta. Now, we can replace k by a because we know that k is equal to a, so c is equal to a alpha beta, or alpha beta is equal to c by a, or alpha beta is equal to constant upon coefficient of x square. It means that the product of the zeros of a quadratic polynomial is equal to c, which is a constant, divided by the coefficient of x square. So, two very important relations we get from the zeros, that is product of zeros is equal to c upon a, or the product of zeros is equal to constant upon coefficient of x square. Now, what we have to remember is if p of x is equal to ax square plus bx plus c is a quadratic polynomial, then the sum of the zeros of the quadratic polynomial is equal to minus b by a, and also the product of the zeros alpha beta is equal to c by a, and a very important thing to remember. Please remember that. Now, the next important study is the geometrical representation or graph of a quadratic polynomial. Again, I will repeat, geometrical representation or graph of a quadratic polynomial. The graph of a quadratic polynomial is a very important graph known as parabola. So, the graph of a quadratic polynomial is a parabola. Remember that. If p of x is equal to ax square plus bx plus c is a quadratic polynomial, the parabola has two shapes. That means we get a parabola. This is the parabola here. The parabola has two shapes depending upon whether the a, that is the coefficient of x square, is greater than 0 or less than 0. If it is greater than 0, then the parabola opens upwards, and if it is less than 0, it opens downwards, as we see here. So, that is very important for us to remember. So, the graph is a parabola. The parabola opens upwards if a is greater than 0, and it opens downwards if the value of a is less than 0. Now what is the geometrical meaning of zeros of a quadratic polynomial? Now what is the geometrical meaning? We know what is the graph. The graph is a parabola. But what is the geometrical meaning of zeros of a quadratic polynomial is what is our study. If p of x is equal to x square plus bx plus c is a quadratic polynomial, now we know that it can have a maximum zeros of 2. It has got the maximum zeros possible are 2. The zeros of the zeros are the x coordinates of the points where the graph of a quadratic polynomial cuts the x-axis. That means that the parabola cuts the x-axis in two distinct points, then that is the different cases are possible. So if it cuts in two distinct points, that means the coordinates of the point P are alpha 0, coordinates of point Q are beta 0, alpha is the x coordinate of point P, beta is the x coordinate of point Q. Therefore that means this particular parabola has two zeros. That means the zeros are the x coordinates. Alpha is the x coordinate here. The zeros are the x coordinates of the points where the graph of the quadratic polynomial cuts the x-axis. Here the parabola cuts in two distinct points. Therefore this particular quadratic polynomial has two zeros, and both the conditions we have taken here, one is the upward looking parabola and the other one is the downward looking parabola. In both the cases the graph cuts the x-axis in two distinct points, and therefore the number of zeros are 2. So the graph cuts the x-axis at two distinct points, so the polynomial has two zeros. Now if the graph cuts the x-axis in only one point, here in both the cases, then it has got only one zero. Remember that. Now if the graph does not cut the x-axis at all, then that is the case number 3. That means the polynomial, that is the quadratic polynomial, has no zero. That is very important for us to remember. So there are 3 cases possible, and each case we have to understand. Now what is the how do we verify the relationship between the zeros and the coefficients of a quadratic polynomial? Now we have to verify the relationship between the zeros and the coefficients of a quadratic polynomial. Let us understand this through an example. If the given polynomial, that is quadratic polynomial, p of x is equal to x square plus 7x plus 10, and we have to verify the relationship between zeros and coefficients. We already know what is the relationship. That is the sum of the zeros alpha plus beta is minus b by a, and the product of the zeros is c by a. So let us assume here alpha and beta are the zeros, then alpha plus beta must be equal to minus b by a. And what is b here? It is 7. And what is a here? 1. Therefore minus 7 by 1, that is minus 7. So we have the value of alpha plus beta as minus 7. Now what is alpha beta? Alpha beta is c by a, and c is, as we know, it is 10, and therefore alpha beta is 10 by 1, and that is 10. Now let us find the zeros of the given polynomial x square plus 7x plus 10 by factorization method. Since it is a trinomial, we can go for middle term splitting method, and then pairing them, grouping them, taking the HCF common, we get two factors, x plus 5 and x plus 2, and x plus 5 is equal to 0, x plus 2 is equal to 0, x is equal to minus 5 or x is equal to minus 2. Therefore alpha is minus 5 and beta is minus 2. When I take the product of alpha beta, that is minus 5 into minus 2, that is 10. Therefore alpha beta by c by a also we got 10, and by taking the product of alpha beta by finding the factors also we got 10, and therefore alpha beta is 10, c by a is 10, and therefore 10 is equal to 10. Therefore alpha beta is equal to c by a is verified. That is the relation between the zeros and the coefficients of a quadratic polynomial is verified. So also we can verify alpha plus beta. Alpha plus beta is minus 5 plus minus 2, that is minus 7, and also alpha plus beta is minus b by a, which is also minus 7. So therefore the relationship is verified. Remember that. Okay. Now method of writing a polynomial when sum and product of zeros is given or zeros is given. Now what is the meaning of this? Now we have to find out a method of writing a quadratic polynomial if alpha and beta are given to us. If alpha and beta are the zeros and are given to us, then what would be the relation or formula to find out or to write the quadratic polynomial? Now let us see how we can do that. Now if ax square plus bx plus c is a quadratic polynomial, then we can express it as the product of two factors, that is x minus alpha into x minus beta, where k is a constant. And when I multiply these factors, then I get kx minus k alpha into x minus beta. Then applying the distributive property, we get kx square minus k beta x plus k alpha beta. Now taking the k and x common, we get k alpha plus beta into x plus k alpha beta. Then taking k outside as common, we get x square minus alpha plus beta into x plus alpha beta. That means x square minus alpha plus beta into x plus alpha beta is nothing but a quadratic polynomial. Therefore therefore if alpha and beta are given to us, then we can find out the polynomial by the relation x square minus alpha plus beta x plus alpha beta, where alpha plus beta is the sum of the zeros given to us and alpha beta is the product of the zeros. So knowing alpha plus beta and alpha beta, we can write on the quadratic polynomial. Therefore remember, the required polynomial is x square minus sum of zeros into x plus product of zeros. Don't forget that this is a minus sign. So knowing the sum of zeros and product of zeros, we can write the polynomial. Now for example, the sum of zeros is 6, the product of zeros is 9. Use the relation x square minus alpha plus beta into x plus alpha beta. Alpha plus beta is 6 and alpha into beta is 9, and therefore the required polynomial is x square minus 6x plus 9. But be careful whether the zeros are given or the sum of zeros are given. Whether the zeros are given or the product of zeros are given, generally the mistake done is zeros would be given, they will the zeros are given, it is easy, but if the sum and product of zeros are given, then be careful, don't add 6 plus 9 and multiply 6 by 6 and 9 and write the find the polynomial. Therefore remember, be careful when you solve the examples. Okay.